Good morning, and thank you for letting us give a presentation on Pegasus and on Condor Week. So as Mark mentioned, we are happy to talk about our latest release of Pegasus, which we released late last year, which has a lot of new features, which might be of interest to this community. So in general, when people think about Pegasus, they always have this question, why do you want to use Pegasus? And, I'll just follow up on Patrick's talk that, some of the issues that Patrick raised might be reasons for people to consider Pegasus. So what Pegasus ends up doing is it automates complex multi-stage processing pipelines, and it sits on top of HTCondor daemon. So internally, Pegasus does use Condor daemon as the workflow executor. It enables parallel distributed computation. And then on top of daemon, what Pegasus provides is a notion of a data flow. So it automatically manages the data for your workflow on your behalf. Descriptions are portable, so they aid reproducibility. As your workflow executes, we do record a lot of runtime provenance database information that we make available in our debugging tools and our workflow dashboard. We handle failures, building again on top of a lot of daemon features. We keep track of data and files. And in addition, we do ensure data integrity during workflow execution at the workflow level. So as a user, you don't have to worry about what's happening underneath. And as Mark mentioned, Pegasus is a NSF-funded project since 2001, and we have a close collaboration with the HTCondor team. So what are some workflow challenges across domains, which a lot of users usually come across? One is, as your workflows get complex, you want to describe them in a simple way. Your workflows become bigger, you need more resources. Sometimes you need to get data from, serve data from both heterogeneous data and resources. You have to deal with how your underlying middleware evolves. By that, I'm talking about the underlying infrastructure. And then as a workflow developer, you need to think about ease of use. You develop some workflows. How do your end users use it, and how are you able to debug and monitor these workflows? So in Pegasus, historically, our focus has been along these lines. In terms of the description, we have a clear demarcation between what your workflow description is and what the workflow execution looks like. So you can take the same description and run it on different execution environments. I'll go into it a bit later. In Pegasus, we have this concept of workflow planning. So, you given your workflow as input, and then Pegasus tries to plan it for your target execution environments. And in this process, has the ability to restructure your workflows, taking into account scalability and performance issues. We've also, over the years, put a lot of effort on task execution monitoring, fault tolerance, debugging, and a web dashboard. And then recently, we've also tackled this issue about how do we try and give a guarantee to users that the data sets are not accidentally or maliciously tampered with as the workflow executes. So some key Pegasus concepts, and they'll be explored more in detail in a tutorial later today. So Pegasus as a package basically consists of three parts. There's the Pegasus Planner, there's the daemon, which serves as our workflow engine, and then we rely on SCHTCD to get the job submitted. So, Condor is used as a broker for us to interface with, Condor pools and other different schedulers also, such as local clusters. In Pegasus, all workflows are DAGs. So, nodes indicate jobs, edges, and dependencies. Planning occurs ahead of execution. And you can think about the Pegasus planning process more like an abstract work as a compiler, where it takes in an abstract workflow description and compiles it into an executable workflow that can be run. So one of the key differences between Pegasus and you writing your own DAGs is the Pegasus input workflow description is a portable description. So when you describe your workflow to Pegasus, you don't have to worry about low-level execution details. So you just specify what your computational recipe looks like. You refer to both your codes and your data sets using logical identifiers. So you're not pinning down their locations when you're describing the workflow. When this workflow is passed to Pegasus, then it ends up generating the executable workflow, which is a Condor Dagman workflow. And in that, as this figure illustrates, you will see additional nodes automatically added by Pegasus. For example, a data staging node will be added to stage in inputs for the workflow. As your jobs execute, there'll be cleanup jobs that remove the data that's no longer required. And the outputs that you are interested in have stage out jobs associated that get staged out to a server of your liking. And your outputs are also registered in our catalog so that you can discover them later. So at a high level, the Pegasus deployment looks as follows. We have a workflow submit node where basically we have Pegasus and HTCondor installed. And the HTCondor installation here is more like the submit node. From a user's perspective, they think about their workflows as follows. So they run their workflows on a submit host, targeting one or more compute sites, which can be your local clusters, your cloud instances, or open science grid. Your data sets can be on one or more input data sites. They can be co-located with your compute site or can be totally remote. And Pegasus does optimizations wherever necessary. There's a notion in our model about a data staging site which coordinates data movement for the workflow. So you can use remote servers, such as, for example, when you're running in a cloud environment, you can use Amazon S3 as a data staging site to coordinate your data movement for a workflow. Output site is where your output data is placed. By default, when you run a Pegasus workflow, each Pegasus job or Condor job gets wrapped by a lightweight Pegasus Lite instance that allows us to manage the execution of that job on that node, where we bring in the data from your data sites or staging sites and ship the data out. So this model, taking it further, I'm not going to spend too much time on this slide, but this shows how Pegasus, LIGO PyCBC workflows use Pegasus to run their workflows on Open Science Grid, where input data is hosted at multiple LIGO data sites. Some of the input data sets might be available via CVFMS, and then the Pegasus jobs can discover them at runtime and symlink against them. And for other files, we have the workflow staging jobs that stage in those input files. As the jobs run, the intermediate outputs go back to this data staging server, where this refers to some grid FTP servers in Nebraska. And as the outputs are generated, our workflow stager jobs will transfer the outputs to a LIGO output data server. I briefly mentioned earlier, so some of the new things which we've been doing also has, introducing integrity checking automatically in Pegasus. So by this, what we mean is, as a user, you have an ability to give us checksums for your inputs. If you don't give us checksums for your inputs, we'll compute them on the first transfer and then try and assure that the checksums match whenever those data sets are used. So at each point in the workflow, wherever there is data transfer or a data set is used, we do validation of checksums. And this helps you as a user, where you are insulated from trying to figure out whether the underlying data staging infrastructure has any checksums inbuilt or not. In late last year, we introduced a major release of Pegasus called 5.0, which again, in this release, we've come out with the new and a fresh Python 3 API to compose workflows, submit and monitor them, configure all our catalogs. So it's a brand new API developed from the grounds up, which we will be going in more detail in the tutorial. It has new catalog formats. Essentially, all our catalog and user-facing formats have been moved to YAML. With the 5.0 release, we have a Python 3 dependency on the submit node install. So all Pegasus tools are Python 3 compliant. We also provide Python pip packages for workflow composition and monitoring. And we've also invested a lot of effort to make it easier for users to use Pegasus out of the box. So literally, there is zero configuration required if you don't want to run a Pegasus workflow on a local HTCondor pool. On the right, I have a simple snippet of how you would do for a simple hello world job workflow and run it locally. And we have focused on data management improvements like having more output replica catalogs, automatically track outputs of your workflows. The whole documentation was revamped, and there's a new tutorial also. So, for example, in this case, there's zero configuration required. So by default, Pegasus assumes certain sites which are used as execution sites if a user does not specify it. And site local internally for Pegasus still designates the submit node and is used to run Pegasus auxiliary jobs wherever possible. So with the 5.0, we've also taken a crack at a new functionality, which is called the Ensemble Manager, where over the years, a lot of our users have been asking us about better ways to submit a collection of workflows, also ensembles. So they want Pegasus to be able to manage a collection of workflows on their behalf. In the past, hierarchical workflows have been one solution for them. The other things which the Ensemble Manager has to worry about is, automatically triggering submission of workflows. And then in Ensemble Manager, we have various ways of controlling your workflows. For example, workflows within an ensemble may have different priorities. Priorities can be changed at runtime, and you can limit the number of planned and running workflows on your ensemble. Additionally, in Ensemble Manager, you can pause, resume, remove, replan, and re-execute workflows. There's a debugging mechanism also provided to investigate failures in workflow runs. And actions can be performed both on ensembles and single workflows within ensembles. So the Ensemble Manager builds on top of Pegasus, and the next upcoming major release of Pegasus 5.1 will have more features added to the Ensemble Manager. So Michael had mentioned about triggers. Ensemble Manager also has a notion of triggers. So we have a cron-based workflow trigger, which allows users to automatically submit workflows at regular occurring time intervals. And we build on this trigger to also provide a file pattern workflow trigger, where new input files matching a given file pattern will be passed as input. It's ideal for regular batch processing of data as it arrives in one or more given directories. So I have just a quick animation of how Ensemble Manager works. So let's say, as a user, you have two ensembles given to the Ensemble Manager to manage, and there are different number of workflows in there. You can specify how many workflows in an ensemble you want running at a particular time. The Ensemble Manager will hand these workflows over to Pegasus for planning, submission, and monitoring using the priority controls specified here. And then Pegasus ends up submitting these workflows to Condor for workflow execution. In 5.1, we will also be exposing a REST API for Ensemble Manager, and the main purpose of it is to make Ensemble Manager easier to integrate in higher level tools or application specific tools. We plan to provide the usual CRUD operations on Ensemble's workflows and trigger. We will be providing both a Python and a Java client code, and import support for integrating Ensemble Manager into larger systems. And this brings me to the end of my talk. This slide has useful pointers for people wanting to look at Pegasus again, or if you have done in the past. So for support, we have a users mailing list. You can also send dedicated support requests at Pegasus at --support@isi.edu. We have earlier this year launched a Slack workspace for our users, where our user community is getting together to ask questions to the developers. We have office hours at a bi-monthly cadence. So there's one office hours coming next week on Friday. And we also have a YouTube channel where you can listen to pre-recorded talks. And here I've been a Pegasus in 5-minute short video embedded for people to give it a try. And this brings me to the end of my presentation, and I'm happy to take any questions.